camera concept. And a high-end system from phase one. This camera is normally used on man-bearing systems, often in conjunction with airborne laser scanning systems. So this camera is 100 megapixel, costs about $50,000 to $60,000 depending on the lens you use. But we have a special copter for that. Phase one is a cooperation with the German manufacturer of copters. But I think meanwhile you can use this camera also on the DJI Matrix 600. So here in front you can see both cameras, same use X4, the one adapted to the Phantom 4, and this one here is usable with the Inspire. Okay. So when you check a photogrammetric system, there are some factors which have influences on the quality of the whole system. And these factors are at once the camera concept. So here you can see our 3 cameras used. The flight parameters, beginning with the image data format. You can use raw data converted to TIFF, which is uncompressed, or normally and often used the JPEG format with some image loss. The second thing is the flight configuration. There are different parameters to do that. So normally you make a regular flight, like in man-bearing aerial photogrammetry, or you do a cross flight. A cross flight is a very good issue for camera calibration. I think we will see it afterwards, and we use it, I think, all the time. A sub-parameter is the number of ground control points and the checkpoints. You can see quality, you can check accuracy in combination with these parameters here. A last parameter is the software. We heard something about that before. So at Bochum University, we use those 2 systems, Agistor Photoscan, so meanwhile Metashape, and Pix4D Mapper. Okay, to check those systems, we built a test field. Test fields for aerial photogrammetry are very often used for camera calibration. The manufacturers of cameras meanwhile do this in this way. And we have a special UAV test field that we fixed in Zollern Colliery. It's an industrial monument in Germany. And we have an area of about 320 meters and 220 meters, so about 7 hectares. And we have distributed 45 ground control points here in a regular situation, and there's a high precision geodetic network with point accuracies of 2 millimeters. So this are our targets on the ground, and here we have some Siemens stars for radiometric evaluations. So this is the site you can see here, Germany, somewhere Essen. I think nobody knows the city outside Europe. There is Dortmund, maybe Borussia Dortmund, a famous football club. So and this is Zollern Colliery. Okay. So to compare those cameras, we decided to make a flight concept, which results in identical ground control sample distance, GSDs. GSDs for all cameras are 14 millimeters. This results in different flying heights. So this is normally forbidden in Germany. Flying above 100 meters means you have to get a special permission for that, but it's possible. Okay, here you can see the flight arrangement, the regular stripes in blue, and the cross flights in red. They differ about 20% in the height. That's a typical configuration we fly. Okay, so next thing, to get some information about the geometric quality, we do a bundle block adjustment at the end of the structure for motion process, and we get several results, and one of the results are the so-called root mean square errors, RMSE values, at once at the ground control points and on the other side on the checkpoints. And these parameters are those issues where we prove the accuracy of our systems. So I hope this slide is not too complicated. It shows two things. We show the results for the semi-use X4S divided in two parts. This part here concerns the ground control points, the results at the ground control points, and that part on the other side shows the checkpoints. So we have a look at the left side. At the beginning I told we have a configuration of about 45 ground control points, and in our calculations we reduced the number of ground control points from 45 to 22 to 12 and to 5 at the corners of the area and in the middle. And there you can see the effects on the RMSE values. They are shown here. So with a great number of GCPs, the 3D error is minimized and it grows slightly. And even when we have 5 GCPs, it is smaller than the ground resolution. You see the ground resolution, the GSD is 40 millimeters. This is the scale here. So on the other side, you can see the checkpoints. And when we have 45 GCPs, there are no checkpoints. When we have 22 GCPs, there are 23 checkpoints. It's a difference. 12 GCPs means 33 checkpoints, and 5 GCPs means 40 checkpoints. And there you can see at the checkpoints, you can see the real quality of an image block. Yeah, you can see model bendings or something like that. No? How the block really acts. And you can see in this example, as for the semi-use X4S, these results are really good. They are always below the ground resolution. So we try to investigate 3 cameras, and this looks something like complicated, but I think it's, if you have understood the slide before, this is almost the same here. So you can see the results for the semi-use X4S here in the middle. Here you can see the results for the phase 1, and here for the X5S, the standard camera from the Inspire. And when you have a look at the 3D arrow, you can see, depending on the number of GCPs, the RMSE values rise, but they rise almost in a very small way, even with the X5S. But then we take a look at the checkpoints. This is below this blue line. And you can see the phase 1 and the semi-use X4S act in a almost familiar way, but the X5S is much worse. So this is a really interesting result. And I summarized it here. The problem of the quality, the problem with the X5S is the unstable camera concept, the possibility to change the lens, which makes the whole system unstable. So this camera is also costs about $2,000 or $2,500, 3 times more than the X4S. You shouldn't use it for a UAV application. Yeah. So this is one thing we tested, and another test concerns the software. So normally companies have one software and they do their calculations with one software. So at the university you can play with softwares, and we have those both here. And we tried to calculate the same image blocks, the same configuration, default configurations with those both softwares. And here you can see the results. The results are shown at the ground control points on this slide, and on the next slide they will be seen at the checkpoints. So this is calculation for phase 1, IXU. Now, something's missing there. Oh, something happened. This is, okay. Normally here you should say, you could see PIX 4D, and this is the line for Archisoft photoscan. This is PIX 4D calculation, this is Archisoft photoscan. PIX 4D calculation, Archisoft photoscan. I don't know where the signs are. And what is interesting, look at the last row here, is that the results with the same data is different. The RMSE values are different. So using PIX4D, they are normally much smaller than using photoscan. And the same thing can be seen at the checkpoints. There are differences in checkpoints, and these differences are sometimes really great. So when you do jobs where you are looking to get accuracies in a sub-centimeter area, what should we do? To whom shall we believe? Is the one software the correct one or the other? And this is my last slide. I would like to say, is there something wrong with the software? So what is going on? It's something astonishing what happens there. And I think software providers should help us to find the reasons for that. Yeah?
Absolutely.
So until you do topographic measurements with a new UAV, that is of nearly no interest. But the time will come that we make engineering surveys, yeah, and maybe you will measure in a sub-centimeter or millimeter region. So that's it. The investigations carried out that there is a certain necessity for UAV test fields to check systems under comparable conditions, and I think we have built such a system. And this data here will be part of an initiative we will start with the German Society of Photogrammetry and Remote Sensing. In this year, we will make an internet platform and provide this data there, so everyone can check systems using our data. So, thank you very much for your attention.